Our Sun is just one star among hundreds of billions in the Milky Way galaxy. The Milky Way itself is just one galaxy among hundreds of billions more. With numbers this vast, it's natural to wonder if other planets out there might harbor life. Could some of these planets even be home to intelligent beings, perhaps far more advanced than ourselves? The sheer scale of the universe suggests that we are unlikely to be alone. Yet we have no direct evidence of extraterrestrial life. No signals, no spaceships, no signs of alien activity, nothing. This discrepancy between the high probability of extraterrestrial life and the lack of evidence is the crux of the Fermi paradox. This paradox is named after the physicist Enrico Fermi, who famously posed the question, "Where is everybody?" His simple query highlights a profound mystery that continues to intrigue scientists and the public alike. The Fermi paradox isn't about proving or disproving the existence of aliens. It's about confronting the profound implications of our apparent solitude in a vast and seemingly silent universe. The story goes that Fermi, during a lunchtime conversation with colleagues in 1950, casually raised the question of extraterrestrial life. Given the vastness of the universe and the immense timescales involved, he reasoned that even if intelligent life were incredibly rare, there should have been ample time for some civilizations to develop advanced technology and spread across the galaxy. Fermi's colleagues were initially dismissive of his query, considering it a frivolous thought experiment. However, Fermi, known for his sharp intellect and ability to reduce complex problems to their core, persisted. He scribbled some calculations on a napkin, demonstrating that even with conservative assumptions about the probability of life and the speed of interstellar travel, the galaxy should be teeming with alien civilizations. His impromptu calculations shocked his colleagues. They had never considered the implications of the vastness of the universe in such a tangible way. Fermi's simple question, "Where is everybody?" cut through the speculative fog surrounding the topic of extraterrestrial life and transformed it into a scientific puzzle. In 1961, astronomer Frank Drake attempted to formalize Fermi's back-of-the-napkin calculations into a more rigorous framework. The result was the Drake equation, which estimates the number of detectable civilizations in our galaxy. This equation considers factors like the rate of star formation, the fraction of stars with planets, and the likelihood of life evolving on those planets. The Drake equation doesn't provide a definitive answer, as many of its variables are still unknown. However, it serves as a useful tool for thinking about the factors that influence the prevalence of life in the universe. By plugging in different values based on our current scientific understanding, we can get a range of estimates for the number of potential alien civilizations. Some optimistic estimates suggest that there could be thousands or even millions of civilizations in our galaxy alone. However, even with these optimistic assumptions, the vast distances between stars present a significant hurdle to communication or contact. The Fermi paradox, therefore, isn't just about whether extraterrestrial life exists, but also about its detectability. One possible solution to the Fermi paradox is that we are truly alone, or at least among the first intelligent civilizations to arise in the Milky Way. This rare Earth hypothesis suggests that the conditions required for complex life to evolve are extraordinarily unusual, requiring a perfect storm of cosmic coincidences. Perhaps Earth's unique combination of a stable sun, a protective magnetic field, plate tectonics, and a large moon are essential for life as we know it. If even one of these factors is absent or significantly different on other planets, it might preclude the emergence of complex life forms. This possibility is both humbling and unsettling. It would mean that our planet is a cosmic oasis, a rare cradle of life in a vast and otherwise sterile universe. However, it's important to remember that our understanding of life is limited to what we observe on Earth. Life elsewhere might take on forms we can't even imagine, thriving in conditions we would consider hostile. Even if life is abundant in the universe, The sheer distances between stars could be the primary obstacle to encountering other civilizations. The Milky Way galaxy is about 100,000 light-years across, meaning that it would take a beam of light 100,000 years to travel from one side to the other. Even if a civilization possessed technology far exceeding our own, traversing such vast distances would be an immense undertaking, requiring vast amounts of energy and time. Imagine trying to send a message to someone on a distant continent using only smoke signals. The message might take lifetimes to arrive if it ever did. The vastness of space acts as a cosmic speed limit, making interstellar travel an immense challenge. This could explain why we haven't detected any alien visitors. They simply haven't had enough time to reach us yet. Or perhaps they have visited in the distant past, leaving no trace of their presence on a young Earth. Some theories propose that extraterrestrial intelligence might exist, but chooses to remain hidden from our view. The zoo hypothesis suggests that advanced civilizations might be aware of our presence, but are observing us from afar, much like we observe animals in a zoo. This idea, while speculative, raises intriguing questions about the ethics of interstellar contact. Would a technologically superior civilization consider it ethical to interfere with a less advanced species like our own? Or would they choose to remain hidden, observing our development without directly intervening? Another possibility is that advanced civilizations might exist in forms or dimensions that we are unable to perceive. Our current understanding of physics might be too limited to detect their presence. Just as ants crawling on a sidewalk are oblivious to the humans walking by, we might be blind to forms of life that exist outside our current frame of reference. Even if we were to receive a message from an extraterrestrial civilization, would we be able to understand it? The way we communicate is shaped by our biology, culture, and evolution. Alien communication might be so utterly different from our own that we wouldn't even recognize it as a form of communication. Imagine receiving a radio signal that encodes information in the quantum states of subatomic particles. Or perhaps their language is based on complex patterns of light and sound that we wouldn't know how to interpret. The challenge of deciphering an alien message might be akin to trying to understand the language of dolphins or the waggle dance of bees. We might detect their signals, but without a shared frame of reference, their meaning would remain elusive. The Fermi paradox could therefore be a matter of miscommunication rather than absence. A more sobering explanation for the Fermi paradox is the Great Filter hypothesis, which suggests that there's a barrier or bottleneck that prevents most civilizations from reaching a certain level of technological advancement or longevity. This filter could take many forms, from self-destruction through nuclear war or environmental collapse to natural disasters like asteroid impacts or gamma-ray bursts. If the Great Filter lies in our future, it suggests that humanity might be on a path to self-destruction, and that technological advancement might ultimately be our undoing. This possibility is a stark reminder of the importance of global cooperation and responsible stewardship of our planet. However, the Great Filter could also lie in our past, meaning that we were extraordinarily fortunate to have overcome a challenge that extinguished countless other civilizations. This possibility offers a glimmer of hope, suggesting that humanity might be an exception to a cosmic rule, a species that has beaten the odds to reach this point in its evolution. The Fermi paradox is a reminder of the vastness of our ignorance. We are just beginning to explore the cosmos and understand our place within it. While we have no definitive answers to Fermi's question, the search for extraterrestrial life continues to inspire scientific inquiry and ignite our imaginations. The silence of the universe might be a sign of our isolation, or it might be a test of our ingenuity. Perhaps we are meant to be the ones to break the silence, to reach out across the vast cosmic gulf and connect with other intelligent beings. Whether we are alone or surrounded by a symphony of alien civilizations, the Fermi paradox challenges us to confront our assumptions about the universe and our place within it. It compels us to consider the possibility of other intelligent beings, their motivations, and their destinies. Ultimately, it reminds us that the greatest discovery we might ever make is not out there among the stars, but within ourselves.